Hey guys, welcome back to Pharaoh Iron & Customs. I'm Michael, and today we are going to rebuild my Bridgeport mill vise. Whenever I started tearing it down to clean it up, I found it had some issues, and the issue is it has cracked in half at some point. I've already taken video of disassembling this vise, and I'll show that now.
Hey guys, I'm recording the sound off camera. I had intended on recording the sound off camera for this entire project, but we'll get into that later. At this point, I'm just trying to show that I had already started taking the vise apart. It had 4 Allen screws that held the jaws in. I have seen some videos where the Allen screws were actually flat-headed slotted bolts, and use a screwdriver to take them out. I'm also showing where there's damage to the vise and where it's been welded back together. Sorry about the noise from the fan. It was very hot that day. When cleaning out the Allen screws that hold the weigh plate to the ways of the mill vise, and I did find, after I got the vise disassembled, there is a hole that had like a dowel shoved in there and sanded off smooth and painted over. I don't know if I show that later on in the video, but there is actually a hole, and you don't have to cut off an Allen key to get these bolts out. At this point, I just started tapping the screw free and was able to slide the whole assembly out, and I think I had a little trouble getting this off and had to get something to pry it off, I believe. Yep, there we go. Just popped it loose with a screwdriver and misused my pair of channel locks there. At this point, I'm screwing the lead screw for the vise out. All of the parts will need to be cleaned and probably just a good repaint. I'm not going to go super wild with getting this up to speed. I just want it to look nice and be able to do the job it was created for. At this point, I'm showing how out of flat the vise face is. And you'll notice the closer it gets to the stationary jaw, the more out of whack it gets. There's actually a dip there that I just hit, but it goes somewhere close to probably 20 to 30 thousandths low, and then goes 15 thousandths high, where when the vise was reassembled, it was welded about 15 thousandths high. I mean, which is probably not bad, being that it was, you know, welded.
Okay, so now what we're doing today is from about this point to here, it drops 30 thousandths of an inch, and it's probably more on that edge right there. And then the step right beyond where it's built up, that's 15 thousandths up. So, and oh well, you can't tell because I need to get those out before we put it on the forge. You can't tell, but when it's on the mill table, you can see the 15 thousandths of an inch rock on this end. So I'm gonna build this up. What I've got is 2 pounds of 99% nickel rods. And the reason why I went with 99% nickel rods is because 99% is, you can mill 99%, you have to grind the 55%. I think it's 55% is the other rod, and it's already hot. It's 8 o'clock. It's 8 o'clock and it's already hot. So let me get those 2 feet off of there. I'm gonna put this in the vise in the forge. We're gonna bring it up to, it should be between 400 and 900 degrees before you try to weld cast. So we're gonna bring it up some. We're gonna do the best we can with the tools I got. The forge is lit. Why the heck on earth is the forge lit in June? Because I'm a glutton for punishment and I need to get this done. So let's get after it. Okay guys, I've got my Everlast TIG set to stick, and we are running on negative is we are running negative electrode, which is reverse polarity on stick welding DC. That's what the instructions called for on the rod, is to run negative and to run at between 80 and 120 amps. So we're going to start at about 86, 85, 86 amps and see how the bead lays down. We want it to weld, but we do not want it to cut, cut and then have pockets. So anyway, there's the vise. I'm going to flip it over and try to get the face of it, and we're going to rotate it a few times and try to get the heat even on it. Oh guys, I hope that's the fork and not the daggone vise. I was not paying attention and we got it hot. So we're going to have to remill the bottom anyway. Just going to and the fact that it's turning colors and you can see that blue in there, that is a very good indication that it's hotter than 400 degrees. So what we're going to do, we can only lay down, I think I'm going to fill in this hole right to begin with. And there's a hole right there. So we're going to fill in these holes right to begin with, but you want to weld about 1 inch, and I'm using my small ball point, my small ball peen. They said to grind a chipping hammer down to a dull point and peen the weld. Yeah, it's laid back down. We're going to have to machine the bottom of this to get that flat anyway. I already had that. I already knew that. So we got a ground, we got our welder, we got our welding helmet. We'll run a couple of beads and then I'll finish it up and we'll come back. Ooh, let's run the welder underneath there so we don't burn the lead. I do need to find my other welding glove. would definitely say we may turn that down just a little bit. Grab this other. I think we may be able to fill those in. The fact that I'm not able to balance on the workpiece is a problem with my shaky hands. This may not take the 2 pounds of rods that I think it's going to take. Let me grab my brush. I don't think we're going to lose the heat in this. It was very hot. And if we screw this thing up doing this, you know, it was already to the point where I really couldn't use it. So, we've got to fix it. I need to put a little more weld right there. Alright, I'm going to start just running stringers and I'm going to jump around to try to keep the heat in the material. Whew. That's hot. That is a nasty looking weld. Do something like this. Okay guys, I'm going to get this welded up and we'll come back. Okay guys, I got the current cranked up to about 105. And I did try to run the polarity reverse of what was suggested. And it did not make it better. They say this is not a pretty running rod. Of course it's probably picking up the grease and stuff that's in the pores in this cast. So we're just rocking out with it, man. Weld about an inch, brush flux off, clean it down. So you can see on the edges where it's picking up the cast, it's not welded very nice, but when you start getting to where it's bleeding back over into the rod that's already there, the welds are looking a whole lot nicer. I have probably burned up, I'm on my, this is the 7th rod so far. And that was hot. Okay guys, it looks like my memory went full. I don't know how much I got when I was recording earlier, recording some beads. But I got this fully covered, and I've ground some of the pits out and re-welded some places. It looks like the cast, you know, has just the natural porosity of cast makes this hard to weld. It was welding really nice here, and I was like, why is it welding so good here and welding so bad over here? This is where and it occurred to me it's already been welded once. So the nickel rod does an exceptional job of welding back to nickel, and you know, that cast, maybe if we'd sandblasted it, that cast, it may have welded a little better. I don't know. I did very little cleanup. I wiped it down a little bit and burned it off in the fire over there. That should have, and the base, when I said 400 to 900 degrees, the base was actually to, it was to a dull red heat by the time I got back to it. So, you know, worst case scenario, this thing is ruined, but it was not really usable in a way in which I could use parallels and make my cuts accurate. So, and that's what we're going for. We may have a little porosity in this bed when I get done, but it's not going to be perfect because, I mean, it was broken, and I could work on it till the end of time, or we can make it as good as we can make it and go on to the next thing. So, with that being said, I'm about to throw my fire blanket and wrap it up and let it cool down slowly as it will in that fire blanket. It may even be better to put it in the oven at 400 and drop it 100 degrees every hour, but we don't have that option really. Next week we're going to do some machining. Hopefully, if you know everything goes smoothly, we're going to put this thing back on the mill in the next day or two and mill the base down and get it ready to go back together. So I'll see y'all in the next video. And if y'all aren't subscribed, go ahead and subscribe and hit that notification bell so it'll let you know when that next video comes out. I'll see y'all later.